Welcome, everyone, to the Tulsa.net user group. Tonight, Eric Johansson from Sweden, all the way from Sweden, going to talk to us on the repository pattern from chaos to order, using the repository pattern the right way. Eric, thank you so much for being here tonight. I greatly appreciate it. And if you would, do a quick bio about yourself and tell us who you are on Twitch.
Well, we'll get to that, but thank you very much for having me. Uh,
All right, take it from here.
yeah. All right. From chaos to order, using the repository pattern the right way. This presentation is actually a huge bait and switch. Since it's an extremely opinionated topic, the actual title should be, according to me. I'm going to show you a couple of examples. I'm going to show you what I've learned about how to use a repository pattern, how to integrate that with unit of work and making it not just efficient, but also testable and everything else. So let's start with the absolute basics. What are they? They've been around for a bit. We used to call them something entirely different. We used to call them data access layers. Back when we did, old three-layer architecture. We had the DAL, the BLL, the business logic layer, and the presentation layer, which is the UI. Today we call it repositories, facades, and views and view models. This actually goes through, quite a lot of things. We used to call what they call ML, genetic algorithms. I used to run these back in the 90s and I could do like a couple of thousand tests a second. And today we use slightly bigger models and do billions of tests a second, but it's basically the same thing. So a repository is a repository of information. It's where we can put things. And yeah, this is me. You can see me over here. That's my boss. Since when I do this live, I'm standing right in front of people and having my huge profile on the projector is kind of boring, so I figured I'd bring my cat as well. She's slightly lazy. I am the author of a add-on to Studio called NoDocs, which I might show off if you want me to. It's nothing advanced, but it helps presenters, it helps coding, when you're coding with someone else or showing things and you don't want to show everything, you don't want to dox yourself. I do live coding on Twitch, and I do that once or twice every single week for a couple of hours. It's quite fun. Sean mentioned earlier, talking to a wall instead of actually having a face, and I will tell you that I am slightly used to talking to a wall since my interactions are pretty much via chat there. I'm a developer, aka owner, janitor, doer of all the things at Seric, and my name is Eric. You might be able to connect those dots. Since January, I am a Microsoft MVP, and I'm very happy and grateful for that. And I'm also a second year Progress Telerik champion. So let's start with the negative. Why should we not use the repository pattern? Well, as it says on the slide, I can, by the way, also mention that I am terrible at PowerPoint, so we will not be PowerPoint heavy in this presentation. It is yet another abstraction layer, right? We tend to like over-engineering things. We add abstractions to abstractions to abstractions. As you can see in the picture on this slide, we have a cake with many, many layers, and it can get pretty hard to follow along with the code. If we're using repositories, we cannot have a fully normalized data store. We need to have the information that we want where we want it, even if the master record might be somewhere else. Going through an existing database and removing things like keys, foreign keys, and constraints feels really icky, right? It's not something that's, you're been taught to normalize things to the third degree. Or you could do it more, but third degree is pretty normal. In this case, you want to take a few steps back from there. And that is because you'll be working against multiple repositories and you don't know if the data store that's backing them is the same anymore. There are performance concerns, since you won't be able to do just as advanced joins. If you're spreading your information out, you might need to make more calls, database calls. And it actually takes a little bit longer to implement because it adds code to your solution, right? You can't just go in and request data directly from the data store. You have to add another layer in between. So let's switch it out. Why should you use repositories? So you centralize your data access. If you're not using repositories, you are most probably, at least, or almost guaranteed, you're accessing your data all over the place in your code. That means that if you change anything in how you store the data, you'll have to go back to all these places and update that. That makes it not terribly maintainable. I will tell you, I love Entity Framework, and moving away from it was painful, but it also turned out to be way, way better. One of the reasons for that is we used to put everything in a SQL database, right? We used to have a data store where we put all our information. If we had images, we would put them in a var binary field, which was basically a blob storage, binary large object. It was easy. We had a database, we put everything there, we had a single backup, everything just ran. Today, though, there are quite a few more options out there. Instead of just having everything in a single SQL database where, it worked, we have cloud services, we have blob storage, we have document databases, and all of these could do a better job of storing specific data. Not everything has to be tabular, right? Some things are better without a schema. Some things are better on a service somewhere else. By using repositories, the source of this data is now swappable. So not everything has to be in the same place and not everything has to stay where it is. If you're doing a migration, you can build a repository for your data that is talking to where it is right now. Then you can build a new repository to where you want it to be. You can migrate, and the end result for your logic code is nothing at all. On that side of the world, it'll just keep working. You can reuse tons and tons of code. You can reuse your entire repository if you want to access it in multiple places. And that also means that when you do changes to it, they fall through to all of the places where you're using it. Testing is so much easier if you're using a repository. You don't need to mock out an entire database and seed that and make everything, put an actual database there, especially if you're using multiple services, and you might be. You might be using a SQL Server database with Entity Framework or with anything else, Dapper, for example, to store your data. You might be using a file system to store images because you've taken the first steps here to splitting your data up. How do you mock out file system calls? Those are static calls. It's not entirely obvious. One way would be to use, what's the name, the interceptors in .NET these days. That's painful. With a repository, you can just mock out the implementation, and where the data is, doesn't matter. If it's a mock, if it's an actual database, yeah. Remember though, they don't always fit. There's a minimum project size where you might not want to use a repository anyways. It's always overhead to add them. And if you're doing a small one-off, if it's something fairly simple, it's a good pattern, don't overdo it. I've mentioned Entity Framework a couple of times. A lot of people say that's a repository. It isn't. It isn't a repository. What it is it's a transactional unit of work-ish library. What Entity Framework does is it has leaky inserts and updates, meaning that if you have related information, it will leak its inserts over to that related information, which can lead to unexpected behavior. You put your data access code among your actual logic code, which again, it makes it harder to test. But do use it. I love it, but use it inside of a repository instead of directly. Not sure if you've heard this term, because I think I've coined it myself, interface-itis. If there's one thing that we as .NET developers love doing, especially since DI became a first-party citizen, I think is the word, back in .NET Core 1, is creating interfaces for everything. Quite often, we create interfaces where we don't need to. Or at least I do. I know my faults and then I keep doing it wrong anyways. For this though, again, we're making a pluggable architecture. Interfaces are awesome and generics are king, right? Abstract classes are also wonderful. They go hand in hand with the generics being king. Because if you're open to having multiple different data in the same data store, not everything in the same data store, but you can have multiple different pieces. You don't need to implement everything from the beginning, right? So you can have shared code for a data source. We'll be looking at some of those in this presentation. But then on top of that, you have the specific code, the stuff that only fits for this specific repository. This is something that took me longer than I want to admit to realize that creating a method isn't expensive, right? If you need to get data of a certain kind to do a certain thing, right? Creating a method for that, it's fine. Doesn't matter if your repository has 4 methods or 400. If you have 400, you might want to organize them a little bit better, but there's nothing wrong with it, really. And with these specific interfaces for different repositories, you can go beyond basic CRUD. Each repository has an interface and one or more implementations. What do you say about us doing some code? As I said, I am not very good at PowerPoint, and I don't really like PowerPoint. However, I am a live coder. So we have this. This is maybe not the most exciting application in the world. I really dislike when people do the draw the rest of the owl thing, if you know what that is. I don't like people just pasting in code from nowhere. However, I'm going to paste in code from nowhere. What that is I have a small project right here that has some data sources. We can start on the other side. We have a base type, which has an interface, and we have an abstract record that only has an ID. We also have a couple of data objects. So we have a to-do object. We can actually start for where we're going to start. We have a lane object, for example, that inherits from base type. And we have a data source. This is just so we have something to work with. We don't need to create everything from the absolute beginning, if that makes sense. Let me see if I can get rid of a window here. There we go. So let's create as a repository, shall we? First of all, we probably want a folder. Repositories feels like a good idea. And if we're going to do this, as I mentioned just previously, interface itis. I am great at it. A repository will have a type, right? We will need to work with a data type. I just realized I don't think I have a reference between these. So let's add a project reference to that. Bang, and I believe that is the wrong keyword. There we go. So we got a constraint saying that a repository can only work with things of base type. So what do we want to be able to do in all repositories? Well, we need a get, right? And let's start with the return type. I want to get. And we need a cancellation token on that. I like this pattern for one more reason, actually. I am really bad at using cancellation tokens, but by starting low, I force me to use cancellation tokens in the actual repositories. That means that I'm reminded to add them the entire way up to the UI, to where I'm calling things, which is also why I don't do that. I want that reminder. I want that error, that requirement that I need to add it. So we have a get. For small-ish data or data amounts, we will probably want a get multiple. Let's call that get all. Int offset, int count, and cancellation token. Thank you very much for that little help there. We want to be able to add something, so I guess that could be a task. I just realized that this should be a task of t, nothing else. We want an add method. Let's call object to add, because that's something that we're going to want to be able to do. We probably want to delete. And let's see here, let's return a task for update. Object to update and the cancellation token. This is 100% live, by the way, so I will most probably mess up somewhere. We will want to be able to save this as well, right? So let's create a task, save changes. Let's not do anything to that. There we go. So we have a simple interface. Now, how about we create a repository from that? So as I mentioned, I have a couple of types up here already. So we're going to create a lane repository. And this is going to be really advanced. First of all, we need an interface. And this, as I said, I love creating too many interfaces, but this is a case where they actually make total sense. We have an iLane repository here. What do we want to do? We want to inherit from iRepository of type lane. And there we go. I think I'm actually, just to not get namespace conflicts here, I'm going to change that to lane repo. And what do we need to do here? For now, we don't need to do anything at all. So let's just go in and let's create this repo. So as you saw, I have a couple of data sources up here. These are lists, so let's create a list lane repository. Let's make this public and let's inherit from that. And actually, I just realized I'm going down the wrong lane. So I forgot we need to build something. As I mentioned before, we have abstract classes, right? We can reuse code. Do you guys think that we can reuse list repositories? I think so. So let's create a base list repository. Make it public, abstract. And make it of type T. Let's inherit from our repository of type T, where T is base type. I might be going out in the wrong direction here, but I don't think I am, except it doesn't implement the methods, but that's not odd at all. There we go. Not sure if I need this. I do. There. Extremely exciting, right? To be able to do a repository that you can save changes into, we will need a working set and we will need a source. So let's do private list of T source. And that shouldn't be read-only, no. And we want a private list of T, that is the working set. And we always need a source here. So let's create a list of T data. Source would be data and working set would be data select. I'm not sure if you all know about this little thing here. Probably the best way of creating copies that has ever been made. So what this does is it doesn't add the same reference. It creates copies of all the stuff in data. In this case, get simple. Let's do a return source single or default. And that would be where item would be ID equals ID. And that's why we had the base type. So that we can always look up on this and something is wrong. Right, I need to async this. Right, now I'm getting a warning. This is one of those, I think this is the best way of doing it. And it's not related to repositories at all, actually. But if I do this, that line disappears when I compile it. Now what I should have done, and I'm going to, is in our repository, I'm going to replace this with nullable, because we might be returning null here. And for here, let's do return source skip offset take count to it as to list. There is an async enumerable here. Let's do this. This is not the perfect way. in L, and we want to do await yield return L item, not the right one. I can never remember. Give me 1 second. I'm gonna check my cheat sheet, which I'm sure you guys never use, right? Let's see. Let's go to, here we go. Yeah, it should just be yield return. There we go. And this needs to be async. And to get rid of this warning, we want enumerator cancellation. There. No more warnings. So here's the thing now. The whole reason that we're doing a working set is I want this. Let's do a return task complete task. So I'm building a whole base repository here. Working set dot remove and remove T item. That's actually not right. That should be T an item. And return that. See, I'm doing things wrong, but that happens. Head back to base. We have an update. Isn't there a replace here? Maybe there isn't. Let me just, I'm going to grab some code instead. There we go. Async that. So yeah, I've got some different names here, but the point is kind of the same, right? Bang, and this should actually be working set. There we go. So how do we save this? Well, let's do this. And that should be everything that we need, right? So we're just going to update our source to our working set. And then I guess we can do working set would be the thing again, source. Let's do this. Source. Isn't that right? You know what? Let's do this. It's not perfect. All right, so we've just spent way too long building a list repository. We're going to be copying code instead in the future. Yes, now we have this. So we have iLane repository, but let's use the base list repository instead. Base list repository of type lane. And we need a comma. And what's it complaining about? Does not contain, right. So we need a constructor here. Then we'll take a, what's it called? It's a list example lane source. And let's throw that into a base, and there we go. We now all of a sudden have a repository with lanes. Let's try creating one of those. So lane repository. Let's actually do this. Lane repository. Just example lane source. There we go. And now we should be able to get the data there. So let's do a for each. I'll wait for each lane repository. Sorry. Lane, what's it complaining about? Why am I not getting my thingy? Let's call it lane repo instead. Get all 0, 100, none. Let's actually create one of those. And let's set that to none just so I can reuse that. Do a CT. There we go. So we have an async enumerable. Let's do a await for each on that. I have no idea what it's complaining about right now. Let me check my cheat sheet. Because we all have one of those, right? Oh. There we go. Obviously. Let's just write these out. Right line L dot name. Let's add the index as well. Let's run it, and we have created our first repository that reads from a list. Except forgot to remove a exception. There we go. So we have a bunch of lanes. Planned, committed, in progress, etc. So what will happen, do you think, if I go into program again? And I'll do mark to-do lane. And let's do a lane repo. Let's actually do an await lane repo dot get. And let's do what's the ID of the first lane? Lane source, that would be 1. So if I do something like, I don't know, to-do lane equals to-do lane width. And then I'll do a update on that. To-do lane and the CT. Let's print this out real quick. Right, so we've got the new name updated. However, if I go into here again, to do lane 2, remove that thing. And then we'll write that. What do you think this will be? We're back to planned. That's because we haven't actually saved our data yet. It's down here. Let's do an await lane repo dot save changes. Like that. We can run it. Now we're getting updated from both. So here's an issue now then. Let me try to create something a little bit more advanced. So we'll create some sources, some repositories for the other sources. So we have a list, we want a to-do repo, and we want a people repo. Now, instead of me spending ages, rewriting all these, I'm going to grab people repo. I'm going to paste that, and I'm going to grab to-do repo, and I'm going to paste that. And we can have a real quick look in here. And I actually shouldn't have done that. Let's remove those lines. And same thing in here. There we go. Sorry about that, guys. I just doxed what we're going to do. So for now, we have the interfaces. I guess we'll just do what we just did. Let's create a lists people repository. And we're going to do what we did just a second ago. We're going to inherit that from base list repository of people, person, actually. Yeah, person. Bang. And what are we complaining about? Yes, we need a constructor. Uh, let's see here, example, list example, people source. I'm going to send that into the base. There we go. Now all of a sudden we have a people repository, and we're pretty much going to do the same thing to the to-dos as well. List to-do repository. Bang. I'm going to call this to-do, and to-do repository. Switch this over to a list. Sorry, a to-do source. There. So now we have repositories for these as well, which means that if we really want to, I'm going to clean up some code here. We can do let me create these up in the same place. We have to-do repository, to-do repo. That's named differently because, oops. And a people repository. And a people source. And now we can just, go through these. Actually, let's not. I'm thinking, guess what's in there, right? Now, though, assume that we have to-dos. A to-do is in a lane. Here's one of the gotchas. Because how do we get that? We could do, the dumb way. We could do just, var all to-dos equals to-do repo dot get all 0, 100 ct dot to blocking numerable. And I think that takes a CT as well, doesn't it? Yeah, it does. So we have all to-dos. We can just do a for each var to-do in all to-dos where t dot lane ID equals L dot ID. Right? That's an extremely greedy way of doing it. Sometimes this is not wrong, because you have to remember, we can't do greedy gets as is to match, how should I say it? This is an extremely greedy get, but it's pretty much all or nothing right now. So how about, let's make this a little bit more sane, shall we? Let's head on over to the repository here. And we're going to do a async enumerable to-do get to-dos by lane. Right? So we have one. Could add another one, and another one, and another one, and another one. As I said, if you have 400 of these, it'll be a little bit messy, but you don't have to have all of them in the same place. So in this case, we just want to implement that. So let's do a public async enumerable of to-do. Get to-dos by lane is, I believe, is what I called it. And now got rid of that warning. Now, let me check here. Yes, I didn't do it wrong. I did it wrong. Because this, actually both of these, oops, that was wrong. These both need to be public. Or sorry, these both need to be protected. There we go. So in this case, we'll do a return matches. There is a better way of doing this. I just can't remember right now. So let's do source dot where t dot lane ID. That's just, wait. No, yield return m. And that's supposed to be matches, nothing else. And this needs to be an async as well, right? So I'm getting a warning over here. It wants it to be an enumerable counts later. Close enough. So if you jump back to here, in the lane, we can now get our to-dos for lane. And let's just do a 2-blocking enumerable on this. There. And instead of, getting all of these, we can do that. Let's see if my copy and paste works. It does not. To-dos for a lane. Title. All right. We have planned, buy coffee, ask who might want tea, and fill the water tank. In progress, we're locking the door, etc. So all of a sudden, we have 2 repositories here. Why is this also great? We have 0 cross-contamination between these 2, beyond the ID, which is just a static value. That means that if we ever want to leave monolith and go modular, which is one heck of a buzzword at the moment, we're halfway there. And we'll be back there when we start looking at different ways of doing this, which we'll get to soon. So some code. It took a while. Not sure if it took longer than I expected, but it definitely took a while. Let's see here. Yeah. So let's have a look at the next part, and that would be unit of work. If you don't know what a unit of work is, it is a work package. If you've ever used database transactions, it's a one or nothing or all or nothing way of working. We use it to make sure that we keep integrity and keep consistency. That gets extra important when you're dealing with multiple data sources and multiple data stores. But how can we guarantee that something gets saved to all the data stores at once? And the problem here is that we can't really. And that is a really bad answer. What we can do is we can add a retry policy here, and we can order things by risk. So we can more or less keep track of our own transaction and then roll back towards multiple data stores, or we can take the one that's most likely to fail do that first, and then we do a sane ordered fail state from there, right? So what we're going to do, we're basically just going to loop over our repositories and save those from the unit of work. A save will not actually save. A save in the repository won't actually push to a database. We'll save to a working set, which if you're working with external databases might mean you get an ID, might not. But to actually commit things, you need a unit of work. There are a couple of different ways of doing this. Because you need to somehow connect your repository to your unit of work. And there are a couple of different ways. One is to have a repository type property. This means that I have my unit of work .todo repo, my unit of work .people repo, for example. Another way is to use get repository, which, I mean, it looks better, right? You don't need to add a new property every time they create a new type or create a new repo. You will never forget that. Problem here is that you will need to bust your DI container, which you might not want to do either. The pattern that I like is attach. I inject an instance of a iLane repository. I inject an instance of my iUnit of work, and then I attached my repository to that unit of work. And just in case you didn't get bored of me coding, let's do some code. I'm just going to switch papers real quick because I have my notes here as well. Right. Let's go in here. Let's create a new folder. Let's call this unit of work. As usual, interface itis, unit of work. And what do we need in this? Well, we want a attach. Task attach. And here's an issue. What are we attaching? Well, we want to attach an iRepository of base type, right? Let's do that. So now we're getting complaints. Name iRepository does not match type parameters, yada yada. It's complaining because we can't really do this, and I am doing something wrong. Yeah, that's what we want to do. And as usual, we want a cancellation token. There we go. This is not going to work because we need a list of these repositories, and we can't have a list of repositories with different base types like that. What we need is we need a way to consolidate these into a single interface. So let's jump on over here. I'm going to create something huge. Public iRepository. Sorry, interface iRepository. And let's see here. We're going to inherit this from iRepository. There. Now, instead of doing this whole thing, we can just do iRepository there. And we also want to be able to save changes. Actually, sorry, want to open transaction. Let's skip the cancellation tokens for now. You get my point there, right? We want to be able to commit, and we want to be able to roll back. And that should be pretty much it. So let's create a simple unit of work. We're going to do this as a fake unit of work. Here we go. And we're going to inherit from that. Implement the missing members. So we need a way to keep track of these. So we will do a private repository repositories. And this is supposed to be a list, by the way. And in this case, we can just do repositories dot add. Now we're going to return. And in this case, these are going to be no ops. Because this is a fake, as I said. There. However, when we commit, we do want to do something. We want to loop over the repositories that we have. And we want to save those. Now, as you can see, we have repositories, but we don't have a save on this. And if I remember correctly, if I do that, I do have a save changes, but I can no longer attach. I mean, there's no way to attach the repo that's of different types to this, which is why we're going to do that. But that also means that we need to move save changes up a step. Instead of having save changes down here, we're going to move that up to there instead. Jump into here and we can do save changes. And like that, and we'll want to await this, which means we want to async this thing. What can we do now? Well, we have a unit of work, which means that technically what we should be doing, I'll remove this again. Let's go down here. Let's create the repo. So I unit of work, UOV. There. Now we can do UOV, attach, and let's attach the lane repo. There. Now the UOV has knowledge of the lane repository. That also means that if we get a, we'll get, I don't know, let's get the first lane again. So let's zero lane equals, oh wait, lane repo dot get, sorry, my brain stopped working there for a second. There, now we have a lane. We can do var updated lane would be lane with name updated lane. We will, in this case, update that in the repo itself. And then instead of calling save changes on the repo, which we could do, but in practice it won't actually commit to the database, we'll do a await UOV dot commit transaction. But this will actually require us to also have an open transaction first. So you want to do a await UOV dot start open transaction. There we go. So in this case, we are using UOV to actually start and close the transaction and actually being able to push things to the database. So in conclusion, what have we looked at? We've looked at denormalizing your data in a way that makes sense, and it is painful. I know that, but it is a good thing in the end. We've talked about letting your repository grow, right? Not everything has to be the default, just get, retrieve, CRUD, create, retrieve, update, delete. Interface IDs isn't always a bad thing, and base classes will save you time. Now we do have one more I can show you, and that is one of the strengths of the repository pattern. I'm going to copy in yet another file, and that would be, let's see if I look at my repositories. I have another people repo here called file. And I will need to include some things. We can adjust this namespace. What this does instead is it saves to disk. And in this case, we don't return a bool because I've actually modified it a little bit. So we're just going to do a return. There we go. So why is this so great? Well, now we can read from file instead of just from a static list. But what if we want to do a migration? Let me remove this as well. I could actually, let's just clear it out. There we go. Let's create a list repo. List people. List people repository. And let's also create a file people. There. What would you do if you want to migrate all your data from one data store to another? Well, would be list people dot get all 0. Let's do in 32 max value and CT. Why is it trying to create a method out of that? There we go. Isn't it max value? There we go. Now we're cooking. Grab all the people. In this case, we'll just do await file people dot save add, sorry, P. And afterwards, we want to do a file save changes. So what did we just do? Well, since we're always working with the same data objects, we just created 2 different repositories and we moved everything. So just for order's sake, I'm going to open this folder here. If I can just find the click open folder in File Explorer. Going to bin, debug, net9. We have nothing. We run this. And I sure hope this is going to work. Now we have a folder here called people with a bunch of very secretive, if I remember correctly, JSON documents. Yeah, Charlie Brown. So in that way, you just migrated all our data from a list, could be a SQL server, could be whatever, over to somewhere else. So that's everything from me for tonight. I hope you've learned something at least, and that I've been able to impart some ideas to you. You can find me on Twitch, twitch.tv/Thindle, which is my streaming nickname. You can send me an email. That's my work email right there. I'm on LinkedIn, I'm on X, I'm on Blue Sky. Yeah, I'm in tons of places. You can find all the slides and the example code over on GitHub. And please do leave me feedback so I can try to do this better next time. This is actually the first time that I've live coded the entire thing without using any, pre-written snippets. But thank you.
Very cool. Thank you, Eric. Appreciate it.
You're
All right. There
welcome.
is a question that came in. into the
Just quick,
chat.
if anyone wanted to see no docs, this is no docs, right?
Oh,
It
nice.
takes your values and your attributes and it hides them. And afterwards, I can click here to display them. So yeah, sorry, terribly sorry. Let's
No, I'm gonna hit you up about no docs.
yeah.
Um, that looks good. I'll definitely use it.
Mm-hmm.
Um, all right. So the question is, suppose there are methods that perform parallel for each looping, and within the loop, they call the repository for insert update operations. Will this
Mm-hmm.
work?
Yeah, absolutely. I mean, you're working on a local data set of some kind. You only actually push to a database once you do a save. And if you're using a unit work pattern, you only push to a database once you actually commit the whole thing. What you're doing in between there, as long as your data source supports parallel reads, you're fine. But again, it depends a little bit on your data source. But if you're using the unit work pattern, you're not actually pushing to the end result before you finish everything.
All right. Very cool.
Did that help?
Yeah, let us know if that helped answer your question. And if there's other questions, please put it in chat or come off of mute and ask. You're more than welcome to. He said, yes, that answered the question.
Mm,
Good
yeah.
deal. All right. Let's see. Would be fun to see the retry example. Ooh.
The retry and the unit work. Yeah. So have you ever seen Poly?
Mhm.
It's basically a retry pattern for HTTP client. I do not have a good example of this, but what I've done in practice when I've done this is I have pretty much put everything in a try catch. I've had a counter and a sleep. So that's a manual poly more or less. So I try to save things. If it fails, I'll update my retry counter. I'll try again in a second or so. And if something fails after a while, I log this thing out the wazoo, right? If you can do a graceful fail, I log it and then I throw an exception going out. That exception has information about what has been saved and what has not been saved, which repositories managed to run and which failed. Yeah. Brian, the source code is available. Let's post a link to it afterwards. And sorry, I just jumped forward a little bit there.
That's okay. Yeah.
Yeah.
You're welcome to stick around after the recording, and then we'll have
Mm-hmm.
the links posted in the chat as well. All right. If we're using Entity Framework,
Yeah.
the common argument is that the EF context and sets implement uniwork and repositories. What benefits
Mm-hmm.
do you argue for?
That is half right. Entity Framework does support unit work. Entity Framework is not a repository. Entity Framework is a single data store for all of your data. Right? You can create multiple EF data contexts, but you'll still have direct access. You'll have your queries inside of your logic code. And that means that everything is harder to test. That means you have less separation. That means that that day when you decide that you want to move away from a single monolith, for example, you'll have tons of, let's call it cross-contamination between different services. Something that I didn't mention is that a repository that we're talking about now is backed by a database or a file store or a static list. What's the difference between a database and a cloud database or a cloud blob storage or my other microservice? A repository implementation in one of your vertical slices could actually call out to a different vertical slice. If I have a people storage, like a people microservice somewhere, if I want to get a person, I can have a repository in this slice that calls out to that service to get the person. You can't do that if you use Entity Framework for everything. Right. I mean, bundled into your logic code. But you are correct that EF does support unit of work.
All right, another question. When designing
Yeah.
domain entities, for example, for use in repository, how do you decide whether to use a record or a class in C Sharp? The code D with the braces works just for records? Question mark.
Yes, you're correct. D with brackets or braces only works for records. I did it this way for code simplicity in this case. Using clauses or using records doesn't really make any difference. Do what you do, right? If you want to use clauses, if you want to have mutable data, go for it. If you want to have immutable data, go for that. It's entirely up to you, and it's the implementation doesn't really care. As I said, I did records here to be able to do quick copies and things like that in the working set copy that I had in the list repositories.
All right.
Yeah.
Yeah, Eric, thank you. Appreciate it. I'd like to
Thank
invite
you.
everybody to stay on after the recording is stopped, and you're more than welcome to hang out, ask other questions, and we'll get you those links as well, and to the repository, and we'll check out a little bit more about NoDocs as well.
Yeah.
Very cool. All right, let me go ahead and stop the recording. Thank you all for coming out, and come back next month. We've got Mitch Sellers.